Hello friends, welcome to Truth of Physics. Today in this video I will discuss on some of the symmetry operations. Basically in this video I will discuss the discrete symmetry. Now what is the symmetry in classical mechanics? I have discussed the continuous symmetry and what actually symmetry means in my previous video. So the link of that video I will give in the description box. If you have not checked that video, then first check that video. Okay. Now in this video I will discuss the discrete symmetry part. The discrete symmetry part contains two type of symmetry. One is a time reversal symmetry and the second one is our mirror symmetry. Now this mirror symmetry, I must cover the mirror symmetry in one particular video. Means the mirror symmetry, to explain the mirror symmetry I need time, so I have made two different videos. In this video I will discuss the time reversal symmetry, and in my upcoming videos I will make another video involving the mirror symmetry. Okay, so what was our goal? Our goal was that Newton's second law, second equation of motion, that is F is equals to the amount of force is equals to m d2 r over dt square. This relation, this equation is this invariant. Is this invariant? We have to check, is this invariant for this type of symmetries? Now we have the particular type of symmetry here, that is time reversal symmetry. Now what is time reversal? Actually, suppose we are having a process. Okay, now in this process, suppose this is an arbitrary path. This is the initial position of the particle, and this is the final position of the particle. Now along this path, this particle or the system is evolving. Okay, this is the final state, this is the initial state. Now this is a particular part. Now if after some time, this takes some time, suppose tf, okay, to go from A to B. Now suppose we are reversing the time. Okay, now this is not actually possible in our physical sense, because we can go only in one direction, unidirection, along the time axis. We cannot reverse back in time, but theoretically we can do it. If we reverse this process, this is B, this is A. If we reverse this, the 2 points are same. Okay, the initial or final. We are just reversing the process, from B to A after TF. Okay, that means the equation is like this. Now our new T dash time, new T dash from B to A in this process, the T dash, the time for every instance, the time T dash is equals to TF minus T. The minus sign denotes that we are reversing in time, we are reverse back in time, and the TF denotes that we have actually go TF in time. After TF time we are just reversing. So after TF time we are just reversing, and this is for an instant. This is suppose at this point, this time, this total time is small t. So this is TF minus T, that is equals to T dash in our new system, in our new reverse back system. Okay, now we are assuming, or we are making the process in such a way that here in this case, in the forward process, each and every part, suppose there is some another, means the force is varying. Okay, the force is varying, but force is varying in a way. Okay, in a particular way, and the reverse process we are making the reverse process in such a way that the reverse process also contains the same category or the same details of the forces. That means in each part of the path the force is just equal or just like our forward process. That means here if F is F1, the force acting on the particle is F1, then obviously here in our forward process the force was F1. Okay, so in such a process we are dealing with. Okay, so here we can easily say that F1 is equals to F2. This is our forward process, this is our backward process. So at each and every instant of time this holds true. Okay, so what we want to do, we want to calculate d2r over dt2 and this LHS and RHS. Okay, now if we differentiate it, then dt dash is equals to minus dt, right? Now what we can do, and we know we are not changing the position of these two particles. That means r is equals to r dash. The forward process and for reverse process the positions are same, so r is equals to r dash. So from here I can write dr over dt for dash, okay, for each dash I am denoting with each dash systems I am denoting with the reverse process, okay, and the normal signs I am denoting the forward process, okay. So dr over dt is equals to what? Dr or I can write dr dash over dt dash, okay, derivative of this with respect to t dash. Dr dash over dt dash is equals to dr as dr is equals to dr dash, right? Now so dr dash over dt can be written as dr over dt dash. Now use the chain rule. This can be written as dr dt dash. Now from here you can write dt over dt dash is equals to -1. So put it here, then you will get minus dr over dt. Dr dash, I'm just denoting the magnitude, okay, not the vector. So dt dash is equals to minus of dr dt. Now differentiate again with respect to t dash in the similar fashion. You will get d2r over dt dash square, d2r dash over dt dash square is equals to ddt dash, or I can use the chain rule, ddt of minus dr dt minus dr dt into dt over dt dash. So this will gradually become d. So for this another sign, another negative sign will appear, so that will eventually become d2r over dt square. So multiply both sides with m, this will be multiplied with m, then you can find that for the reverse, for the forward process, this quantity is equals to the reverse process, same quantity, okay. That, and this quantity was equals to our force in forward process. We know that F is equals to m d2r over dt square. Then that means F is equals to this and this is equals to this, and as we had discussed that F1 is equals to F2, as for each and every point of this path the force is equals to the force in the reverse process is just equals to the force in the forward process. That means from there I can write this, and so combining these two, F1 is equals to this, and F1 and F2 are also equal. That means I can say that this is equals to our F2. That means the force measured, or the amount of force, is just equal to this quantity in the reverse process also. That means in the time reversal process this quantity holds true. That means this Newton's law of motion is invariant under this time reversal symmetry. That means it is symmetric under this time reversal. So I hope that you have understood how to deal with this kind of symmetry. In my upcoming videos I will also discuss the mirror symmetry, which is very much interesting, and to learn that you have to first go through what is a proper vector and what is a pseudo vector, likewise what is a proper scalar and what is a pseudo scalar. So combining these things I will make another video so that you can get the concepts first about these things. So hope this video is very much helpful. Share this video with your friends and take care of yourself. Thanks for watching.